Hello, my name is Rachel, and my project is localization of Phyceta macrocephalus using passive acoustic monitoring, a reliable form of distance estimation for mitigation. So many marine species use sound as their primary means of navigation, communication and foraging, and this is due to the efficiency of sound propagation in water. This means that many marine species have evolved highly specialized sound-producing and receptor organs to utilize this increased sound velocity. The importance of sound over vision can be seen here as a comparison of sperm whales' comparatively very small eyes compared to the size of its head, which utilizes 1/3 of its total body length, which houses all its sound-producing and receptor organs. Changes in the ecology of the ocean, such as increase in noise pollution due to anthropogenic involvement, are therefore likely to have a substantial impact on marine mammals' ability to survive, or at the very least make it more difficult for them. Introduction of anthropogenic noise has been both unintentional, such as the propulsion sound from ships, and intentional, such as Navy sonar and seismic surveys. Human use of the ocean is an essential part of the modern way of life, and it's these social and economic pressures which are responsible for the introduction and increasing input of noise within the ocean. Worldwide awareness of this issue has increased in recent years following a number of stranding events, quite often in relation to anthropogenic noise, such as Navy sonar. Although it's a general consensus that scientific understanding into the implications and effects of anthropogenic noise on marine mammals is currently lacking. It can be assumed that marine mammals will respond much in the same way to terrestrial mammals, so information regarding effects can be extrapolated from data from terrestrial mammals as well as from captive marine mammals. Effects can be both behavioural and physical. Some physical effects. Mammalian hearing is very sensitive. When exposed to high levels of sound, the hair cells within the cochlea become damaged or misshapen, and this can cause permanent or temporary threshold shift, which can result in hearing loss. A non-auditory physiological response is rectified diffusion, which is a phenomenon which causes the growth of microscopic bubble nuclei within the tissue and blood when exposed to a high intensity sound. And this can cause death or injury in diving species, especially deep diving. And there's evidence of this in necropsies from beaked whales, which are very deep divers, in relation to stranding events from Navy sonar. Behavioural disruption is any disruption from normal behaviour. This can be avoidance of a certain area, changing dive patterns, which can lead to disruption in feeding and breeding. Also, there's masking of significant noises, communication or echolocation, which can result in the animals using different frequencies, having to repeat themselves many times, or increase their amplitude, all of which can cause stress. So my project focuses on seismic surveys and the mitigation protocols in place to protect cetaceans. Offshore seismic surveys is for exploration of oil and gas, and it involves generating a high level sound from a highly pressurized air gun, and they basically blast the seabed and read the reflections, and any change in the seabed is recorded. In each seismic array, there are up to 48 individual air guns, and each of these air guns can produce noises between 220 and 240 decibels, and this is referenced at 1 micropascal at 1 meter. An equivalent to this in air is that of a jet engine, so basically being 1 meter away from a jet engine. And just to note that sound becomes painful to the human ear at 130 decibels. Mitigation procedures for seismic surveys vary from project to project, depending where in the world the survey is taking place, the time of year, and the animals that could be present in that area. Generally, during daylight hours, an MMO or marine mammal operator must be present, and in hours of darkness, a passive acoustic monitoring system must be in place. The mitigation zone is 500 metres around the seismic air source, and any animal detected either visually or acoustically in this zone could mean mitigation actions need to take place. There are 3 standard actions. One is the delaying of soft start, which is the sound source starts off quiet and progressively gets louder and louder, giving the animal time to escape the area if And 2 is real-time measures. This is shutting down of the seismic source if an animal is detected within the area. And the 3rd mitigation measure is actually pre-planning of the survey to avoid any important areas. So there are obvious limitations to visual surveying. If the animal's not at the surface of the water, you won't be able to see it. It could be under the water, but within the mitigation zone. There are several limitations to PAM. Obviously, the animal needs to be vocalizing for you to be able to detect it. And also, it could be masked by the vessel noise. The vessel noise is very loud. Obviously, the seismic air source is very loud. Clicks can attenuate very quickly. And also, the anthropogenic presence in the water could also be affecting the vocal behaviour of the animal. So my project compared real-time distance estimations to post-analysis of the same distance of the same detections of sperm whales made by PAM operators using PAMGuard, which is an industry standard software, to assess the accuracy and to see whether it was reliable enough to carry out these mitigation measures. The data was provided to me by Station Measurements, who are a North Devon-based company who make and design and manufacture underwater acoustic and visual systems for mitigation and monitoring worldwide. So I had 12 detections in total from 2 seismic surveys, one in the Gulf of Mexico and one in Nova Scotia. Each detection was analysed by 3 PAM operators. Firstly, each operator would analyse the data in real time. The tracks were queued up in PAMGuard, and the operators would assess the audio track as if they were working on the vessel in real time. They may need to make a mitigation action depending on whether the animal was within the zone or not. To do this, PAMGuard's click detector and map feature was used. The click detector detects pulse type signals, and these are displayed in either the bearing time display or the amplitude time display. Each ellipse is on the display represents one detected click. The space between these clicks is the interclick interval. There is a left-right ambiguity, meaning it's 180 degrees bearing, where 0 to 90 degrees is ahead of the vessel, and 90 to 180 degrees is behind the vessel. This is the PAM map display, and this provides position information for the vessel, for the mitigation zone, the hydrophone array, and the source array. Bearing overlays based on the clicks detected in the click detector are used to estimate the distance to the vocalizing animal. So this click detector here shows a sperm whale, and each of those ellipses in the line are clicks from the sperm whale, and the red ones have been detected by the PAM operator, and the yellow have been picked up by PAMGuard's automatic click classifier. And these clicks have then been tracked and are showing up in the map display. So blue lines are the track lines, and where the lines cross is where the sperm whale is located. So this sperm whale was detected within the mitigation zone. Each PAM operator then would analyse the data again in post-analysis, and they were able to pause and restart the track as many times as possible, being able to select as many clicks as they possibly could to get the most accurate distance estimation. So once the real-time post-analysed detections were localised, several t-tests and Kruskal-Wallis variance tests were run on different combinations of the data. And overall, all analyses of results showed that there was no statistical difference between the real and post-time analysis or between any of the operators. So the null hypothesis could not be rejected. This study has therefore initially shown that PAMGuard and PAM operators are statistically working at a consistent rate, and it is sufficient enough for mitigation. However, there were some differences in operators' distance estimation that would have meant the difference between an action being called or not and potentially unnecessary harm being caused to a sperm whale. So detection 2 is highlighted in red there. The final distance estimation submitted on the report was 500 metres, which is the very edge of the mitigation zone, so a very close call. And then each of the operators in real time overestimated this to 600 metres, which would have meant that the boat would not have been shut down, so the sperm whale could have been caused unnecessary harm. There are a few reasons for this, that this could have happened. The PAM operators could have been erring on the side of caution in regards to the seismic survey vessel. Operations can cost $85,000 per square mile to acquire data, with companies having to spend between $1 and $40 million before they see any of the information. Or the operators on board the vessel could have been erring on the side of caution in regards to the sperm whale, which means that they shut down the vessel even if they thought they weren't sure whether it was on the boundary or not, to make sure that no harm was caused, and that to make sure that the company was acting within regulations. Because if a company is found to be acting outside of environmental regulations, they could lose their license. So further studies, I'd like to have used more PAM operators, but the time it takes to analyse 12 audio tracks twice is a long time, but it would have been much more robust if I could have had more data to compare. Also, the operators obviously knew that they were going to be listening to a track which had a sperm whale detection in it, so they were ready to track that data, which could have meant it would have been more accurate than in real life. So ideally, I would like to create a more real-to-life scenario where they'd have to listen to longer tracks with nothing in it for a longer amount of time, so they didn't know when that track was coming. I'd just like to thank Station Measurements for providing me with the data, to Gemma Stammer and Sarah Bissett, who were the other PAM operators who helped me analyse the data, and to Duncan Jones, my project supervisor, who helped me through the whole entire project. Thank you.